Hello everyone and welcome on the second day of BalCCon and on the first lecture in Pupin. Today Goran and Igor will give us a lecture with the topic reversing and repurposing a resin 3D printer. Thank you very much.
So hi to all and thank you for the arriving. Yeah, on the first session. We know that yesterday was like party and everything. So yeah, thank you. Little bit about me. I am a member of the Radiona makerspace in Zagreb. I am a co-owner of Intergalactic that is doing open source hardware and software development. And my background in work was like 15 years of repairing stuff. So I was a repair technician. And later I switched to design and to do things that are more like smarter. But that hacking thing and designing thing is really similar to the repairing, because when you repair stuff, you actually need to hack them to understand what they do and to get understanding of the device that you can see how it's working and that you can repair it. So that's a little bit about me.
Hi, my name is Igor. I'm basically a software and hardware engineer, maker. I'm also a member, Goran mentioned the Radiona Makerspace. I'm one of the co-founders. I have my own company, Hyperglitch, which does custom hardware development. My Twitter and everywhere else tag is this one. I'll just start with a few words about Radiona, because this project was part of it. So Radiona is a makerspace from Zagreb, founded in 2011. And it's a bit unusual. It's not pretty much a bit different than other makerspaces, because we have it's not a typical hackerspace. We have quite diverse distribution of both ages, like from teenagers to retired people, and it's not just all technical people. We have a lot of artists, a lot of designers, like people from theater. So all in all, combined, we have a very specific both production. We often produce some exhibitions with interactive art, and also organize repair cafes, hanging out and similar. That's it. But with all those projects, one of the most popular ones which came a few years ago was ULX3S FPGA board, which got crowdfunded, and now it's a very popular FPGA board in that world. And Goran, who is CEO of Intergalactic is a company spinned off from the makerspace for producing and distributing those boards. So basically, this project is all Goran's. I just came for one last part, so I will sit here and come back for last two slides. So.
So this project started actually that I was working with one guy, and he asked for service. So for the idea how we could measure, do the machine that would measure those devices. Those are displacement sensors. So those sensors are when you stretch it, it says how much did you stretch it. So so there is lots of those sensors on the market, and we needed actually the machine that will test those sensors, but we didn't want to invest enormous amount of money in the machine that is this one, industrial grade, and it costs $30,000, and it's it do many things. It do maybe it's ultra precision that we don't need, and it has. It can do higher strength, but we didn't need all those fancy stuff. So we just needed a way to measure the displacement sensor, as we wanted to check it how it will work. So we also wanted to check how it will behave on different conditions. So for example, if you heat it, if you are like cold it, so if it'll have the difference, and we just wanted to get the data out of the sensor. And for the start, we wanted to get like 0.1 millimeter precision. So like my idea is always that when I start to work, so I want to make it like cheap as possible, and actually I look around myself and see what is like available for the for usage. And actually the most available things are like open source software and 3D printers. So I started with also like those multimeters, and everything is like inside of my working space. So I have used everything I had at home, so I didn't need to buy any other equipment. There is like really good open source project from Envox. So they are also from Croatia, and they do. It's complex project, so it is called Studio. At first, it was like for controlling the instruments and measurement equipment, but now it's really complex project that can do like GUIs. It supports LVGL. It can run also on embedded devices. It's also platform independent, so you can run many things. So my idea was to use that Envox Studio to create a GUI and to use actually the Prusa printer, because I had one at home. So I started to work with the GUI, I added the temperature sensors and started to pick up the responses from the multimeters and stuff. And actually Prusa was quite easy, because I can just send like Prusa G-code, move Z-axis or X-axis to this location, so I could move the Prusa for like 0.1 millimeter. But the setup was like terrible, because I just taped it down, so it was like quick proof of concept. I just wanted to know if this is actually if I could get those 0.1 millimeter precision. But at the end, it was okay. So I got those sensors that we got. It was actually, those sensors were good, and I could actually move Prusa by 0.01 millimeter. I can tell it to move 0.01 millimeter and then check each step and see how the sensor is moving. But this sensor was not super precise, so, but it was at the, like in datasheet, it was like it was written in the datasheet. So this was like confirmed that approach actually works. So the first step was actually done, and I talked with the guy, and he told me that we need like a little bit more precision. So we started to think about what can we actually use to get more precise measurements. And when I have checked those industrial like equipment, it looked just like the resin printer. So it has just one axis, and resin printers are really cheap now, and they are like quite precise. So they can move up to like 0.01 millimeter. So my idea was that I can reuse the application for the Prusa, and I can just send the G-code to this printer. So that was the whole idea. But yeah, it was not that easy. So the first thing, that printer doesn't have like USB serial or something that I can just send data to it and it will move. The second thing that I was thinking that it is possible, so usually those printers have like Wi-Fi to serial. So I have checked every serial port on the printer, but this specific one that I bought didn't have that option. So that was also not possible to just send serial data to the printer. So only thing how this printer could be like used is to put like USB stick inside and to run some to run like models. So usually those printers are working that it's like slicer is doing like many pictures and it's just showing picture on the screen and move the axis. So then I try to figure out what is like my next step. So I searched the internet and I have found a really cool documentation about reversing the previous versions of those printers. And the write-up on those is really good. So there is like a step-by-step guide what you need to do, how to reverse it. But the authors are actually not available anymore. They have like Discord channel and you can ask there, but there is no authors. But people around the world are trying like to do a reversing on those previous machine. But those are machines are usually not available because that resin printers are like constantly updating and there are like just new versions and new versions. Also the original code, so they have like original code that is written for the complete control of the printer, but it was written in Rust, and on my machine I was not able to compile that code because that would be the easiest way to get it on, like to just adjust it for my machine, but that also didn't work. So yeah, I have started to actually thinking about what can I do. So I have checked the main board of the printer, and the interesting thing, like there is inside there is like Giga device, so that's MCU, and its name suggests that it may be like compatible to STM, but when you start to work with it, it's actually a complete clone of the STM. So everything that works on the STM in the same like with the same name, it will work on this GD device. That is like China company that is actually probably cloning each STM that is available. So yeah, that for that Giga device problem in the Giga device is that toolchain is really shitty, so it's quite hard. It's harder to use than the STM. And as I was working before with the STMs, I was more comfortable with the STM toolchain. And on the printer, the maybe interesting things about the hardware. So it doesn't have any other communications instead of the USB host, but it has like FPGA with the SD-RAM. And the main MCU is sending the SPI commands to fill the frame buffer, and the FPGA is just controlling the MIPI screen that is, it is having like frame buffer that is controlling the MIPI screen and showing the picture on the screen when it's needed. There is nothing super special in the board, so there is a simple motor driver, beeper, buzzer, and like some flash, and that's it. Yeah, I already told you, like it is complete clone, so everything that works on, so you can just build the binary for the STM and it will work on the Giga device. You can also use the firmware that you have. So the board is really good because like most Chinese board, that's perfect. There is no protection, so there is nothing that I would need to care about. You also, like on those board, you also have like headers for the programming and stuff. So you have a header for the FPGA programming and the header for the like Giga device programming. So that part was quite easy. So I didn't need to figure out what is needed to get the binary. Good thing is that the authors of the reversing of Mono 4 created the emulator, and it is really cool emulator. So, but as they at some point 2 years ago they just disappeared, so they left the project in like floating state. But that emulator can probably be reused for many things and many purposes, but. Some of the peripherals is actually missing, and I am not good at writing the code in the Rust, so I was not able to add some more peripherals. And the problem is when you use the binary like inside this emulator, it's just when some peripheral is not available, it's not created, it just stops. So you need to figure out how to jump over some lines, like initializing of, I don't know, serial port, or if it's not available, you need to just use something to move the jumps. And in that emulator, you have one XML file that it's actually a text file that describes patches. So you can, inside of emulator, inside of text, you can apply the patches. I don't have it here. So it's really simple text, and you just need to put the address of the patch where you want to patch to be applied, and you have one application that is actually converting the assembler code to some array that is describing the emulator how to apply the patch. Most patches I have used was just knobs or just jumps. It was like quite, yeah, because I'm not doing the reversing. I'm more into like designing things, but this one like was, yeah, the accident that happened. So so I needed to apply patch, so I saw the emulator running, and it just stops at some address, but I don't know what is happening on that address. So the way I didn't know about the Ghidra, so I knew like from talks, but I never used it before. So I started with this finding out what Ghidra can do, and for the like STM devices, it's really cool. There is a SVD loader that's plug-in, and when you start that plug-in, it will fill out all the calls to the peripheral. So that's like a must-have tool for the must-have plug-in for the if you are reversing the STM devices. And so with the Ghidra, I could actually see what is happening on others that is actually blocking the continuation of the booting. So I mostly did like checked where is the function that is blocking and do the knobs until the end. So that's the how. So I just skipped to our next function. So that was like my idea. So I started to work and step by step, and actually first I wanted to get the screen working, but so those Chinese printers and versions are really crazy, because so the screen is driven by FMC. On the Giga device it's called differently, so peripherals are called differently, but it is the same thing, so they just call it differently. So I noticed that they are using the FNC because Mono 4 had the FNC, but on Mono 4 it was actually done good. So the address line, so that's one pin that is telling the STM hardware that is writing the data or command. So that pin was on Mono 4 was actually set on the pin that is hardware FNC hardware address. So I was thinking, okay, so there is one pin that I need to find, and there was like 23 options or something. But at the end, the Chinese didn't use that. I lose like 2 days on that because I started to like putting one pin like 1 to 3 to 24, building firmware, seeing what is if screen will have some like noise or something, but nothing actually happened. And then I actually started to using the emulator. I saw that they are not using any of those pins to actually start the FNC. They are using it like software. So they just checking if they write to they write data or command, and they are just using the software pin. So some different pin, random pin. That's yeah, bullshit, but they do it like that. So I needed to do it like that. And once I get that, I got the screen actually working, and I got some simple library onto it. So the screen was done and screen was hacked. So actually I just needed to move the motor, so I just need, now I'm like close to the something I need, but now that I have like screen, I would like, I was thinking that maybe everything can, like complete application could run on the, like on embedded firmware, so I don't need like computer or things. So I again used the NVOX Studio to create embedded firmware for the, like, so I can like control the printer quite easily. I also like finding the pinout of the motor was like easy, so I got that part really quickly. And at this point I had like control of the screen and control of the motors. Yeah, I can set the speed of the motor, I can move motor up, motor down, I can calibrate, I can like find the home position of the so there is one switch there and I can find the home position. That's, yeah, that's mostly it. There is nothing super special here. But yeah, I was in control, and that was actually enough for that was shit. Okay. That was actually enough, and for my project, for the displacement sensor, that would be it. So I'm in full control of everything I need. But you know, it's like there is like one more step. So there is like MIPI screen, and it's like we can do more than we have now, because if you control that screen, you can also do stuff for the like Radiona. Like we do lots of like homemade PCBs and stuff. So most people are reusing those printers for the creating the PCBs. So that was like super like good thing to try. So I actually started to work on reversing also that part, because it's not super like complex to like reverse SPI. But I connected my all I had at home, so my all logic analyzers, and all those analyzers like was like catching. I have like many super cheap logic analyzers, but when I got like the data out, it was always like not corrupted, but always different. So I saw that something is wrong. So those cheap ones could like get the data, that much of data that I needed at some like 8 megahertz speed. That was the maximum of those logic analyzers. So I checked on the oscilloscope, and I found out that the SPI is working on 100 megahertz, and that's too much for my 8 megahertz logic analyzers. So I needed to like buy new super expensive, not super expensive, but more expensive logic analyzer, or I don't know. So I slept over the night, and I was thinking, but okay, we are controlling the printer, so I am like, I can check in the printer, what can I do? And not to buy and wait for the like expensive logic analyzer. So I was figuring out that so when you set the like SPI speed, you are actually setting it in one register, and it is like divider of the original frequency. So the Chinese firmware doesn't, it's set to 1, so it doesn't divide the main frequency clock. So I just check in. So I was trying to understand what is like happening with GDRA and this tool like ASM-Pi, and I understood that I can actually apply the patches and check if things are working. I also like asked ChatGPT a few times so that I don't need to like read the complete data sheet of the STM. So I just ask what would be the register and is it possible to do it that way. And after some searching inside of the Jidra, I found that you can like find the address of that register, and you can follow it back. So after that, I have found the function that could be the like setting the divider, and after few tries with different things. So because I was now able to like apply the patch in the Jidra and run the firmware in the simulator, so I can check in the simulator if the speed is actually if the register is changed. So after a few tries, I actually got the register set. I have just applied the patch and put the firmware, new patched firmware inside of the printer, and now SPI is actually quite slow. My machine will be able, my logic analyzer will now be able to catch the data of the SPI. And yeah, after that I just used these logic analyzers to get the communications out of the machine, and I called Igor because I was like lost in all those things. So I asked him if he could help me in like reversing that part. So yeah, then he jumped in.
What Goran actually didn't mention, like a resin 3D printer has that small screen on the front for the control, but it has a 4K screen underneath, so it shines the light onto resin to harden it, then moves the head, and then shines light again. So basically we had a 4K 4K grayscale screen, which would be cool to have control of, because if you have like 4K screen which you can shine onto anything, it could get a lot of uses for that. So basically what Goran did was to record, like put some image on it and record the signals going to it to try to decode, to see what happens, how to control that screen. It wasn't really obvious, but he sent me this thing, and he said, like, you're better with numbers, like, to try to see what's happening. And he basically sent an image of a white square, everything around black background, white square, and got these like numbers, like first 463 times this number was sent, then something, then almost 3,000 times something else, and then this. And on the first look, we can see that it kind of looks like this image, because we have first a completely black part, which is like this 463 of these. Then we have something else, which is like a line which has like black, white, black, something along the whole height. And in the end, we also have like full black lines. So I thought, but when you calculate, when you take the number of these elements, number of these numbers, you see it's not like setting every pixel, because it's a 4K screen. It's like, watch the resolution, 5,000 times 3,000 something. Like, it's a huge number of pixels. So they're using some sort of compression, somehow compressing the data. So it was, and because of this, it looked familiar, but I couldn't get it immediately. So I told Goran to like send me a few more example pictures, like a thinner stripe across the height, and then horizontal stripe, and like just to see how it happens, to figure out where is the color stored and where else. Since so there is some sort of compression, but since this is running on an embedded device, it should be something simple to decode and encode. And basically, when you're using a 3D printer, you basically slice an object into many tiny slices. And those are some blobs, black and white blobs. Basically, we have like bigger areas of single color. So what would be the easiest and relatively efficient way to encode that. It's called run length encoding. Basically, you say like, now goes the black color and the next X pixels are black. After that,
Yeah, and I actually have, like when I was sending him the pictures, I was using like original firmware, and I just put like the object inside like for 3D printing, and I was just pushing I adjusted original firmware with the patch, so I just pushed the object to like print and just capture that part.
So the run length encoding is send a value, now goes next 3000 pixels are black, then next few hundred are white, and so. And that's the concept. I figured that from the first image, but the next thing was like figure out how it's organized, because we can see there are some different some numbers, but like which bits are setting the color, which bits are setting the length, and like just by looking at it with a few more of these examples, I figure out like it's sending 4 bits for color, and the remaining 12 bits is for the number of repeats. And it has 4 bits for color because it can actually display 16 different shades of gray, like from the full black to the full white, and 14 in between. So in this, if we look at the hex view, like we group it as 16 bytes. So the first, this 0 represents black, and it's called FFF times. FFF is like 400. Huh? No, FFFF. Okay, some number of times. We're sending just black. So, and if the like first part is F, that means white, and it's repeated this number of times, and stuff like that. But to test it, I just wrote a simple Python script to like take any image, convert it to that, and another script to like do it backwards to just check if everything's correct. And I sent it to Goran, like I have something, like now test it. So. And he tried, but we had to debug, like find a way to actually send it to the controller, so there were like some small bugs. But after some time, we got this, like we sent an image and we got it on the screen, and it was good feeling, yeah.
So we had the control of the complete printer, because when Igor was working on this, I added also like a USB host reader, so we had like binary. So this Python was just throwing the binary, and I putting on the USB stick, and it showed the image.
It showed the screen. So and basically, with the full control of the printer, we can now do anything. We can do like the most straightforward thing would be to write an open firmware for the 3D printing, and maybe we could do that, maybe not. But there are many interesting uses for that. Goran already mentioned like the PCBs. For PCBs, or even some sort of art with photo exposure, you have a board which has like photosensitive layer on it, and you need to like put a light on it in some shapes, put a mask on it. And you can usually put any mask and light it with a UV light. But with this you have controllable mask. You put anything, you shine it from the bottom, and you have a really good precision to do that. So first thing is PCBs, but if you have like really precise mask which you can shine on something, you basically could do a homemade integrated circuits. It would be that scale, but simple, because integrated circuits, transistors or more complex ICs, basically you need a huge diode which you just put a mask on it and cut some parts of it to do some connections, and basically you have an IC microcontroller. But it's not still for the actual integrated circuit. You need much more precision. But for some simple circuits, even this could be done, because it's a relatively high number of dots per inch, and that can even be focused with another lens. But Yeah. So we asked, Goran asked ChatGPT how it could be done. Basically, it's not that hard. You need some sort of conductive glass, some chemicals to layer over it, and yeah, as I said, you need a way to somehow make a diode and just put a mask on it and etch the unneeded parts and like that.
We also did like that. So we had like one experiment with that one guy from Taiwan was on our like in a Makerspace has a camp once a year. So one guy from Taiwan was at our Makerspace camp. So he showed us like technique with the laser. So and showed us those glass parts. So we knew that it is possible, but he was like laser was not super precise. So he was not able to do it.
Yeah, he's doing it like he's making a homemade photocells.
Yeah.
Solar cells.
Solar cells.
Which is basically a diode, and if you just etch some pattern into it, you can get transistors.
There is also like the guide for the doing yourself like small LCD screens, like those one like old ones that have like the one style, like not like
like shapes, electric crystal shapes, which you can turn on and off.
Yeah,
like
it's also
for
done with
numbers
conductive glass, and you just buy like a bottle of the liquid crystal. So the possibilities like are endless, and I hope that other people from the makerspace will continue the work. I just need that part with the motor.
So yeah, these are some links: Goran's GitHub repo, Radiona's site, and other things. Radiona's Discord, where you can find basically all of us. So
And the GitHub where the current firmware is, so that's open because it's
because this.
so.
So if you have any questions, we will gladly answer them. So thank you.
Do we have somebody who wants to ask something?
Okay. What was the most frustrating thing about the project for you guys?
Yeah, the most frustrating was the finding that pin because I lost 2 days. So that was really because when you set that, so first you need to find the pin, but pin also you need to set the address of the like writing and to data, and so each pin needs to like be set on 3 different locations. So and I have passed like first time, then maybe I skipped one, then back. So it was really like. I could probably do it better, but you know, you always think that the next one will be right one. So yeah, so that was most frustrating. But everything else was like.
And I really love your approach that you like never use Libra and you just use the tool and manage to find out how it works.
Yeah.
And only could patch the binary is a really cool reason.
Yeah. Also patching the like original binary that is just have slower SPI, so I can like actually get the. Yeah, that was cool. Thanks.
And even so the binaries do not have some signature stuff, like if you run the 3D printer, you can just load it into a printer.
Yep. Yeah, and there is none protection, so they probably. Yeah,
Even
they
though
don't.
those STMs and their clones, they do have like read protections, and it's
But
really
this
easily
one-
enabled, but they didn't do that. So
No one has money for that.
it's basically one command when you're flashing it. So, so that's it. If there's no more questions, another question.
I might have missed it because I came in a bit late, but what was your research process to select that particular resin printer?
Yeah, it was like available ultra cheap because it was 200 euros, and I searched for the like good mechanics for that price. So if you just buy the parts for that mechanics, you can end up in like 300 euros, and you can get the printer for 200. So it was like that was the, and it has like 2 sides of the like guiding of the z-axis was like quite precise, and it has some I don't know how it's called. like z-axis, you know, when you move up and down, you have like a bit backlash. So it has like those backlash things that it doesn't have that move. I needed it because of that, because I wanted to measure that sensor. So that was the idea.
Okay, thank you.